What's up, everybody? In this video, we're going to be continuing to talk about SQL statements. And this is another video where we'll start on the whiteboard and we'll finish with the code. I wanted to start on the whiteboard for this video on joins because, at least for me, learning joins at first was a little bit confusing. And what helped me was to look at some visuals, look at some Venn diagrams, and that really helped me when I was writing code. So let's get started. We have our student data, as we've been working with in most of this series. And we'll be looking at the two fields name and GPA. So a student has a name and a student has a GPA. Now for a join, we usually have a second table, although not always. Sometimes you can join a table on itself, but that's for later. We usually have a second table. So in this table, we have job data. And job data will have a couple of columns, but in this case, we just care about the name of the employee and what job they have. So maybe they work at the library, maybe they work in student dining, whatever their job might be. Now, there's information we care about in student data, and there's information we care about in job data. Furthermore, it's not the case that every student has a job, right? Because some students may choose not to work, so they don't appear in the job data. And you might even say that there's certain people in the job data who don't appear in the student data, because some people at a university have jobs, but they're not students. So there is some overlap between these, but there's also some rows that are specific to each of them. So we're going to look at how to kind of deal with that discrepancy. First, a motivating question. Let's say that we're trying to join these two data sets so that we can think about GPA and job. Maybe we want to know stuff about how if having a job affects your GPA, or if having a certain job affects your GPA, things like that. So right now it's kind of difficult to do because our data is living in two different places. So we're going to be using something called a join in SQL to put these data sets together in an intelligent way so that we can answer questions about columns that live in either one. So I've written most of the statement here. We just need to fill in a couple things. Here's how you do a join in SQL. So you select some stuff. We'll fill that in at the end. From, and you write your first data set here, student data, which is our data with name and GPA. It's helpful to sometimes alias that with a shorter name because you can use that short name throughout the rest of your statement. So I'm going to call my student data S. Here's where the magic is. I'm going to be doing something called an inner join. And an inner join, as we'll explain in a second, basically says that only give me rows back where the thing I'm joining on appears in both of the data sets. That'll make more sense in a second. So I'm doing an inner join on my second data set, which is my job data, which I'm going to give the nickname or alias of J. And this is telling it how to do the join. So I'm going to do the join on anytime s.name is equal to j.name. Here's what's kind of happening behind the scenes. It's looking and saying, okay, I need to join student data and job data. Now, I don't know which columns to match up, right? Because there might be several columns with duplicate names in here. It's not really clear until you provide this on keyword. So now you're saying, hey, SQL, anytime we have the name in the student data set match up with the name in the job data set, I want you to put those things in the same row. So now it'll have, let's say, we have a student named Yoda in both cases. So if we have a student named Yoda here and a student named Yoda here, SQL will say, aha, I got a match. So I'm going to put the row in the final join data frame as Yoda, whatever GPA Yoda had, and whatever job Yoda is currently working. Whereas if I have a different student with a different name, it will not put those together because the names don't match. So that's why it's very important to put this on keyword so that it knows exactly what things you would like to match on. And now to go back and explain that inner join, it's only going to give me records back where the name appears in both data frames. So for example, if there was a student in here who is not working a job, that student would just completely not show up in my final result because they don't show up in my job data frame. And vice versa. If I have some professor in here in my job data, but the professor is obviously not a student, then they're not going to show up either. So inner join basically just says that only give me rows where you were able to successfully make the match. Now, let me fill in these selects before we look at the other kind of joins. But we want to get a couple things. So s.name. So let me write these in. Job and GPA. So first to explain job and GPA. Since job only appears in one of these data frames, I'm safe to just write the word job, right? because there's no ambiguity about whether I want the job column from dataset 1 or dataset 2. I could only ever want it from dataset 2. Same thing with GPA. I could only ever be asking for that from dataset 1. But since name occurs in both data frames, I need to specify which one I want. In this case, it really doesn't matter, because since I joined on the name, I'm kind of enforcing that they're equal. So whether I put s.name here or j.name there, it's going to give me the same thing back. But you could think of cases where there's another column that is duplicated between these two, which I'm not joining on, and that column might have different information. So you need to specify which one you're selecting. So that's your basic join statement in SQL. Now, to close out the whiteboard portion before we just look at running some code, let's look at 3 different kinds of joins. So we already did an inner join, where if this is dataset 1 and that's dataset 2, we ask for only records where you get matches on the intersection of the 2 data frames. An outer join is what you might expect. It's asking to give back any time where basically every single record in both data frames should be returned. So basically, if I did an outer join on these 2 data sets here, I'm going to get back students who don't have jobs, and I'm also going to get back people who are working jobs who aren't students. And then you might be asking, okay, if I get back someone who's a professor and they have a job, but they're not a student, what gets reported in their GPA? Well, it ends up being none, or null, as it's sometimes called in SQL, because we don't have a GPA for them. And vice versa. If we have a student who's not working a job, we'll have their name, we'll have their GPA, but their job will just be none because they don't have a job. Sometimes you care about an outer join because you want every single record across both data sets, not just ones that are in both. So that's an outer join, and that would be filling in the entirety of the Venn diagram. Now there's also a left or right join. The reason I just put left because right is just the symmetric version. But on a left join, you only get back records that are in the left data frame you're joining. In this case, that would be student data. If I switch the order of them, then job data becomes my left data frame. Or you could just change the left to a right. So they're really symmetric. So that's an inner, outer, and left or right join. And there's certain situations where you might care about one and not the other. So let's go ahead and look at the code on how to execute this join as well as some other join.
All right, so now let's take a look at how to perform joins using the code. The first thing, obviously, we need to create that second data set, because up until now we've been using just the student data, so we need a second data set. Again, it's not super important you understand how the data is created, but if I do a simple select statement on the data and I limit to just first 20, I'm going to get names of students. I'm going to get their job, so their job can be from one of 5 categories, so dining, library, AV, research assistant, or tech support, and their wage in dollars per hour. And that's the 3 columns that are in the new data. So we're going to be looking at joins by answering a series of questions. The first one is, how does average GPA compare across jobs? This is something we were interested in on the whiteboard. So let's look at how to do it using the code here. The select statement looks pretty much the same as on the whiteboard. So we first do a inner join. We want to inner join in this case, remember, because we want to make sure to capture only people that are within students and the jobs. We do an inner join of student data, aliasing it as S, job data, aliasing it as J. We join on the names, so we enforce that the student's name is the same thing as the job employee's name. And we get back the job, the GPA, and s.name. Remember, we have to put s.name because name appears in both data sets, so we need to be clear about which one we're asking for. In this case, it doesn't matter, because since we enforce that they are matching, it'll give us the same result. Doing so gives us this really big data set, and there's 5,000 rows in this data set. Remember, in the original student data set, there was 100,000 students. When I created the job data, I just picked 5,000 students randomly from the original student data and said that those 5,000 students are employees. And that's why we get 5,000 rows back, because we did an inner join. So it only gives us back stuff that's in both the job data and the student data, which is just those 5,000 working students. So that's why we see that every student has a job, every student has a GPA. So that was step 1, right? Because we care about how does average GPA compare across jobs. So far, we've just made a big data set of students, their job, and their GPA. Now we need to group by job, because we want to know for every job what's the average GPA. So step 2 is just taking the same statement we had and just adding a couple extra features to it. the first one being group by job. So we take this data set up here and group by dining, library, AV setup, all the different jobs the student could have. And then we select the job itself, and we select the average of the GPAs within that job, calling it average GPA. We just had a order by to make things more clear, and we order by the average GPA in descending order, and we get back this much easier to read data set, which has each of the 5 jobs a student could have, and the average GPA of the student within that job. We see that they're pretty close together. Now let's do one more question to get a good grasp of how to use a different kind of join. The question is, what fraction of students within each major have jobs? So, for example, within all math majors, what fraction of math majors have jobs? What fraction of physics majors are working? And we want that answer for all of the 9 different majors. So again, we're going to do this in steps. So the first step is going to be a left join of the 2 tables, student data aliased as S, job data aliased as J, and we're joining again on the names, and we're getting back the major of the student and their job, because we don't care about anything else. We just care about how many students within each major are working. Now, the one thing I want to talk about is, why am I using a left join here? I used an inner join up there, right? So we're using a left join here because we want to make sure to get every single student in the student data. Before, we only cared about students who are working. Here we care about every single student, because in the end we want to get a fraction of how many of them are working. If I did an inner join here, it would only give me back students that are working, so I could never form that proportion of students who are working. So I want to make sure to get back everybody, and then just get a count of how many people are working and divide that by how many people there are total in each major. So let's move on to step 2. Or first, here's the output of step 1. You see that most of them are none, right? Because we have 100,000 rows here, which is every single student. And that's because we did the left join rather than an inner join. And since only 5,000 or 5% of the students overall are working, most of their jobs are going to be none. But we do see every once in a while we get a student with a job. So here we get library, and most of the students are buried within this ... But you're going to see that 5% of the rows have jobs, and the other 95% do not. Step 2 is going to be grouping the result above by major. And then we're going to need to get the fraction within each major where the job is not none, where there is a job for that student. So taking it step by step, most of this is the same as above. The new stuff is we're going to group by major. Now within each major, we're going to ask for select the major. That's legal because we grouped on that category. And here's the slightly more complicated one. We saw a statement like that in the having video, but to explain it again, we're going to be summing up all of the students within each major where job is not null. So where you see these nones up here, you can identify them by saying is not null. Null is a keyword in SQL. Anytime that we don't know what the value of something is, it just assigns that as none or null. So overall, the statement reads case, which is saying if job is not null, which means if the student has a job, then basically add 1 to my counter. Otherwise, if the student does not have a job or is null, then add 0 to my counter. So overall, this sum is going to give me back the number of students within each major that are working. And then since I want a proportion, I just divide that by the total number of students within each major. And I call that frac working because I want it to have a friendly name. After doing that, I get something much easier to read. I get the 9 majors, and I get the fraction of students within each major that are working. Now, step 3, let's just say that I want to get only the groups up here where at least 5% of the students are working. The only thing I really change is I add a having statement. I just put this because I want us to get some review with the having statement. So having fraction of students working, which remember is defined by this formula up here, having fraction of students working greater than or equal to 5%. And just for niceness, I order the whole thing by fraction of students working descending. And I get back 4 of the majors from above. Does that make sense? 4, because I get 1, 2, 3, and 4, where the 5% are higher. I get back those 4 majors, and I have it in descending order of fraction working. And that's it. That's how you use joins in SQL. We didn't do an explicit example with the outer join, but you could imagine an example with that as well. Okay, so in the next video, we'll talk about a special type of join called a self-join, where you're joining a table on itself. Until next time.